Right, so we're looking at theorem 3. If one pair of opposite sides of a quad is equal and parallel, then the quad is a palm. Required to prove the shape is a palm. Okay, so one of the things we can do, we can try and get both pairs of opposite sides parallel, then we can prove that it's a palm. So always work with what is given. So always start off with in triangle. We are always trying to prove congruency. So we're going to start off with in triangle ADC and triangle ABC. We need either two angles and a side or one of the congruencies, okay, that we can use. So let's see what we can find. So we want to find something common in this triangle and this triangle using either alternate angles, co-interior, something that's given. So work with the given. The most obvious given would be the side. AD is equal to BC. So AD is equal to BC. Notice that this mark is an indicator that those two sides are equal. So that's the most obvious. AD is equal to BC. Our reason will be given. Don't forget to put reasons. Can you think of another side that is very common to both those triangles? We can see that AC is common. So AC is common to both triangles. So there we have another side. How about maybe an angle? Obviously we cannot go with another side because this side and that side is not told that they are equal. So obviously another side is not an option. We have to look for an angle. Can you give me an angle that is equal in both those triangles? Yes, if you look nicely, you can see that A1 is equal to C2. So there's our Z shape. A1 is equal to C2. These arrows mean that they're parallel. So A1 is equal to C2 because AD is parallel to BC. Alternate angles. AD parallel to BC. So now we have a side followed by an angle followed by a side. So we have a side followed by an angle followed by a side that will give us side, angle, side. So therefore, those two triangles are congruent. Right. And now we have triangle ADC. Triangle ADC is congruent to triangle ABC. The reason? Side, angle, side. So now that means that this whole triangle fits perfectly on that whole triangle. That means there's a certain angle that would be equal to the other angle. Can you see it? Because we proved the two triangles congruent, we said that this whole triangle is congruent to this triangle, so A2 will be equal to C1. Notice that those are alternate angles. A2 is equal to C1, corresponding angles, because we proved that these two triangles are congruent. But they are also alternate angles. And if alternate angles are equal, what can you conclude? So because they're alternate angles, we can conclude, because they're alternate angles, there's the Z, we can conclude that AB is parallel to CD. Tell me, is this shape a palm? Final reason. Therefore, ABCD is a palm because it has two pairs of opposite sides parallel. So the final statement, ABCD is a palm because it has two pairs. There's one pair, there's another pair, two pairs of opposite sides parallel. Proved. Proving that ABCD is a palm. So they tell us that DO is equal to OB and AO is equal to OC. Don't forget to mark your diagram. You'll notice I've marked it in green between there, and I added a 1 and a 2, and we're going to call that O1 and O2. And we're going to call that O1 and O2. So notice we already given DO is equal to OB and AO equals OC. So we have two sides already. All we need is another angle. Do you agree that O1 is equal to O2? So O1 equals O2. So as we said, O1 is equal to O2. So O1 is equal to O2. Therefore, triangle DOC is congruent to triangle BOC. So DOC is congruent to BOC. The reason is side, angle, side. Side followed by an angle followed by a side. Therefore, DC is equal to AB, corresponding sides of congruent triangles. So corresponding sides of congruent triangles. Similarly, you can prove that AD is equal to BC. Therefore, it's a palm. Both pairs of opposite sides equal.